Hello everyone. Welcome back to our SAT preparatory session. We're back here for our second session now, and let's not waste any more time. Let's dive straight back into where we left off. Okay, so last time we left off, we were talking about unique systems, right? So basically, what that is a question where you have to figure out how many solutions a system has. And last time we discussed, we said that normal systems, which are the ones that you typically solve for in like a normal question, they only have one solution. And then systems that are basically identical will have an infinite amount of solutions. And then impossible systems have no solutions. So to build off of that, we are going to do a little bit of practice. I have these 4 questions for you here, and I'm going to give you guys 4 minutes to do them starting now. All right. 4 minutes are up, so let's come back and take a look at these questions. Okay, so the first question, the first 3 questions are just asking how many solutions does this system have. So right away, the pattern in the first question I notice is that the left side of the top equation is proportional to the left side of the bottom equation, where basically it's been multiplied by 3, right? So we can do the same thing. We can kind of reverse engineer it where we can multiply this by 3 so that we end up, for the top equation, we end up with 24x plus 36y is equal to 30. And then what you can do is we have 24x plus 36y over here. We have 24x plus 36y over there. We can set these equal to each other and then make a statement where we have for the right sides of both of these equations equal to each other. So if we do that, we end up with 40 is equal to 30. Now that is an inherently false statement. That means no matter what values of x and y you put, you're always going to end up with a statement that is false, like this. So therefore, there are 0 solutions. Now, the next equation, there's also another pattern here as well, where the bottom equation is effectively multiplied by 8. And actually, if you just look at the entire equation, they're practically the exact same equation, right? The x term, the y term, and the constant, they're all multiplied by 8 in the bottom equation. So in this case, since they are the same, that means that they have an infinite amount of solutions, or you could say all solutions. Now, the third question, simply all you have to do is just solve the equation if you don't notice any outright patterns. So yeah, let's just try a crack at that. I don't notice any patterns right away, so I'm just gonna solve it. Let's multiply the bottom by 2. Let's rewrite the first equation. And then the bottom equation, let's subtract both of those from each other. We get negative 10x is equal to negative 30. So that means x is equal to 3. And then if x is equal to 3, we just plug it into one of the above equations, and you should get y is equal to negative 1. So we have a solution, 3 comma negative 1. If you're able to get a solution, that just means that there's one solution. Now, the last question is a little bit tricky, especially because it's a question that's trying to make you think in a weird way, and also the wording can be a little bit tricky. The wording is strange, but it does tell you what you need to know. So let's go through this. In the system above, A and B are okay, let me just, that was a little typo. There's no A, there's only B as a constant. If the system has no real solutions, what value is impossible for B? So let's get the one thing straight. We are saying that the equation has no real solutions, just like the first equation over here. So what does that mean? No real solutions? It means that we are creating a false statement, two equations that basically they're never ever going to be equal to each other ever. So if we know that and they ask us what value is impossible for B, that means that there's only one answer that makes it so that we don't have a false solution system. Let me explain. If you notice, there's a pattern over here. The bottom equation is basically 3 times the top equation. So what would happen if we took this same multiplier and we applied it to the 9 over here? If we applied it to the 9 over there, then this b would be a 27, right? So you're probably saying, oh, well, b 27, well, he's asking for what value is not possible for b, right? So that means that it can't be b, right? Because, B, 27 is our answer? No, actually, that's false, because B is actually the correct answer. Here's why. If we put 27 in place of B, then that means that both the top equation and the bottom equation are proportionally the exact same equation. And what does that mean? If you have two equations that are the exact same, that means you have an infinite amount of solutions. So that means that we are breaking the rule that we wanted no real solutions. And how do you get no real solutions? You make it so that B is literally anything other than 27. So if you put 92, that's correct. If you put 23, that's correct. If you put 115, that's correct. All three of those numbers and everything else will make it so that the system up there has no real solutions. So as a result, the number that makes the system have an infinite amount of solutions is going to be impossible for B. And that's why answer B is the correct answer. I just realized I said a lot of B's there because I used a constant B and the answer was B. Are there any questions on that? Okay. Sarita, you have a question?
Yeah, I just want to clarify, don't you mean question number 2? Because if we multiply 3x, it would make both of the equations the same, right?
Sorry, I don't understand.
Like, wouldn't it be like the same as question B's? Because 3 times 9 is 27, and that would be the same as both of them, right? Like,
yeah, exactly. That's my
okay,
point.
okay.
That's my point. Yeah. So do you not understand why B is the answer?
No, I do, but you said it was problem number 1, so I was just confused.
Oh, okay, no worries.
Okay.
Rahul, do you have a question?
Yeah, so I was just wondering, isn't there a shortcut where you can use the matching wheel to see how many solutions are in a system?
The matching wheel, personally, I've not heard of a system like that before, but if the matching wheel is something that works for you and is very quick, then by all means use it.
It's like where you find the ratio of the x's, the y's, and then
Oh,
the
okay. Well, that is basically what we are doing. Like, I'm showing you all this work just so I can be thorough, but in reality, when I'm doing the test or when you're doing the test, you're probably going to be doing this all at lightning speed in your head. And basically, that is what we're doing. Like for the second question, for example, what we did was we just saw the ratio of the x to y, right? Like I can go, oh, the ratio of x to y in the bottom equation is 1 to 5, and then it's same for the top. That means that there's a pattern there, right? Is that kind of what you were getting at?
yeah.
Yeah, okay, yeah. So that's pretty much it. But yeah. All right. Unfortunately, we only have time for 2 questions per slide. So yeah, sorry. All right. How to identify perpendicularity. So perpendicularity, what does it mean? It means perpendicularity is used to describe what a situation where two lines are intersect in such a way where they create a 90-degree angle, a perfect cross, if you will. I'm sure you already knew that though. Okay, this question over here is asking, which of the following is an equation of a line that is perpendicular to line K? So line K is this line over here, and they're asking us, how do we find a line that's perpendicular? So here's the way that you find a perpendicular line. You take the slope of the original equation. So first we have to find the slope. What is the slope? Well, if we just start at a random point, so let's start at x is equal to 1, and we check out what the value is at 2, we see that the slope moved down by -2. So that means that the slope is -2. So the equation is y is equal to -2x. What's the intercept? 1, 2, 3, 4, 5, 6. -2x plus 6. Okay? Now, the way you find a perpendicular slope, the perpendicularity of a line, it depends completely on the slope. The y-intercept or x-intercept, it doesn't matter at all. So the perpendicular slope is basically the negative reciprocal of the slope of the equation that you want to make a perpendicular equation to. So what does that mean? The first part, negative, means that you apply a negative sign to the slope. So we said that the slope of the original equation was -2, right? So simply, we just multiply -2 by -1, and we get 2. And reciprocal means, in a way, sort of the opposite or the inverse. And what it means specifically in this case, if you want to have a reciprocal number, it means flipping the numerator and denominator. So let me explain it like this. If we have the number 3, 3 is technically equal to 3 over 1, right? So the reciprocal of 3 over 1, the reciprocal is basically when you flip the numerator and denominator, the reciprocal is going to be 1 over 3. So let's apply that to this over here. So we already applied a negative sign to the original slope, so we're left with 2. And then if we're going to make the reciprocal of 2, so 2 over 1 turns into 1 over 2. So the reciprocal is 1 over 2. And that right there is your perpendicular slope. So which equation has the slope of 1/2? C has the slope of 1/2. So therefore C is the correct answer. Ritvik, do you have a question?
Yeah, so for the equation y equals -2x plus 6, where did
Yeah.
the 6 come from?
The 6 is the y-intercept of the line that's on the graph.
Oh, okay. Got it. Thank you.
You're welcome. All right then, so let's move on to some actual application. All right, here are some practice problems. I made these unnecessarily complicated because I could, as usual. I'm gonna give you guys, 2 minutes should be enough, starting now. All right, everybody, 2 minutes are up, so let's come back and check out these questions. By the way, I apologize if there's any squeaking noises in the background. This chair is kind of bad. All right. So, which of the following functions is perpendicular to the function above? Okay, so the slope is 2, right? So first we apply a negative sign to it, so it's going to be -2, and then we reciprocate it. I don't think that's an actual word. That's just what I call it, reciprocate. I mean, it is an actual word, but definitely not the verb form of reciprocal. But yeah, so -1/2. Okay, so we got to find an equation that has the slope of -1/2. So A is out of the question. B, if we expand it, that's going to be a slope of 1/2, positive 1/2, not -1/2. So that's going to be wrong. D, -3 times 1/3 is going to be -1 as a slope. So that's going to be wrong. C is going to be the correct answer because 1 over 4 times -2 is going to be -1/2. Okay, which one of the following functions is parallel to the function above? Okay, there's a little bit of trickery in this question. and you have to choose the best answer. This is going to be your first introduction to a situation where it's going to be a sort of vague definition of what the correct answer is, and you have to choose the one that makes the most sense. So we have 1/3 x, so basically parallel, we have to make sure that the slope is the same, right? So A, you might immediately think that, A is the correct answer, right? Because it has the same slope and a different y-intercept. And yeah, you would be correct. A is actually the correct answer. But I want to point you guys to another answer, D, where the equation expands to 1/3 x plus 6. Now, you could say that this is parallel since it has the same slope, but they're the exact same equation, right? So parallel is used to describe two different lines, and these are the exact same line. So even though D, you could argue it is a parallel line, A is going to be the more traditional definition. Okay, let's move on to a word problem. My favorite, not really. Okay, a voter registration drive was held in town Y. The number of voters, never mind. The number of voters V registered T days after the drive began and can be estimated by the equation V is equal to 3,450 plus 55T. What is the best interpretation of the number 65 in this context? Okay, this is an interpretation question. They want to make sure that you can take a linear equation or any math and apply it to a real life scenario and actually understand what each component means. So what does number 65 represent here? Well, 65 is connected to T, right? So what is T? T is the number of days after the drive, right? So V is the number of voters. So if T is the amount of days after the drive began, then any number attached to T, basically the number of voters is increasing, right? And we can infer that 3,450 is like the starting count. That's another, oftentimes y-intercepts are kind of used as the start for the value of whatever data you're estimating with a linear line. So they start out with 3,450 voters, we could say that. And then for every day after, every time T increases by 1, V increases by 65. So every day they're gaining 65 voters, right? So we could say that 65 basically represents the amount of voters that are gained each day. So which answer best follows that? A, number of registered voters at the beginning. Okay, that's going to be false because that corresponds more to 3,450. If we are looking for the interpretation of that number, A would be correct. B, the number of registered voters at the end of the registration drive. So it's going to be the total, the starting combined with all the voters that were added up afterwards. This is going to be false. This corresponds to the variable V, which represents the total amount of voters. C, the total number of voters registered during the drive. Okay, this one's a little bit more specific, but it's still going to be wrong because if we were told to represent the total number of voters registered during the drive, then we would have to say that would correspond to 65T, like that term as a whole, because 65 is only the amount of voters registered in one day. If we want to do the amount of voters registered during the entire drive, which spans multiple days, we have to put the T in there. As a result, D is going to be the correct answer, the number of voters registered each day during the drive. Are there any questions? Nope. Okay. All right. Here is a problem for you guys. I'm going to give you guys 3 minutes to solve this starting now. All right, everybody. 3 minutes are up, so let's come back and check out this question. It's a little bit wordy, but it shouldn't be too difficult to understand. All right, so we have an environmental club. They're trying to collect sponsors. M is the total amount of sponsors they get. And they'll be able to get club sponsors at community event advertisements. So the function M is equal to 2x plus 7 represents the total number of sponsorships that the club has. What is the best interpretation of the 2 in 2x? Keep in mind, x is the number of events that they advertise at. So if 2 is connected to x, then that means that the 2 is related to whatever that they are doing at the events they are advertising. So every time x goes up by 1, m goes up by 2. So that means for every community event that they advertise at, they get 2 extra sponsorships. So we could boil that down to, for every advertisement they have, they get 2 sponsorships. Which answer best follows that? A, for every community event, they gain 1 sponsor. That's going to be wrong. B, for every community event, they gain $2. We're not even talking about money in the first place. C, the club already has 7 sponsors from the beginning. Now, this is a true statement because the y-intercept is 7. That's like the starting point. They started with 7 sponsors, but that's not what we're talking about. D, community event advertisement, 2 sponsors. D is the correct answer. Are there any questions? Nope. Okay. Just saying, if you actually do have a question and you're not sure about asking it, just ask it anyways when I ask, because the period of time that I give for people to ask a question is pretty short. If you haven't noticed, I'm like, all right, any questions? Like 1, 2, 3, and then we're done. All right. So, okay, let's move on to this now. Problem solving and data analysis, ratios, proportions, and percentages. Okay, so the first question, the Pacific Plate has moved around 1,060 kilometers. About how far in miles has this plate moved? So basically, we have to convert from kilometers to miles. Now, how do you do that? You have to create what is basically a proportion or a ratio. They're basically the same thing, just written in different ways. I'm going to be honest, I don't even really know the differences, but they're used in the exact same way. So a ratio, simply you just write a number colon a number. So they're giving us information here. 1 mile is equal to 1.6 kilometers. So we can say 1 mile colon 1.6 kilometers. So that's the ratio for how many kilometers is in 1 mile. And the proportion is like a more applicable version of a ratio that you can use in sort of a fractional way. The way you convert something is by taking the original value, so 1,060 kilometers, and you take this ratio and you turn it into a fractional proportion like this. 1 mile over 1.6 kilometers. And you make sure that whichever unit is on the bottom, it corresponds to the unit that you're trying to convert out of. So if you're trying to convert from kilometers to miles, you have to make sure kilometers is the denominator for this proportion. So all you have to do simply is solve that. So you do 1,060. Oh yeah, one thing I forgot to mention is that it's important to write units because they can help you visualize how things are getting canceled out. You can actually cancel units out the same way you cancel a number. So this km cancels out with that km, so you're left with only miles. So 1,060 divided by 1.6 is equal to 662.5. Now we don't have this exact answer there, but we have 663, so it's safe to assume that they want us to round up a little bit. So C is going to be the correct answer. All right, before we move on to the next question, it seems like we have some questions. Aditi, you have a question?
On the conversion sheets and like the formula sheets, will we be given like miles into kilometers, inches?
Oh, no, don't worry about that's not important at all. They're not ever actually going to ask you to memorize like conversions like that. If they want you to use a proportion, they're going to give it to you. You're going to see that in the future problems that I wrote for you guys, where we're going to give you the proportion information. All we want you to do is use that information. So don't worry about remembering anything. Vishal, you have a question?
So will these type of problems be on like the calculator section, or do we just have to like?
It depends. If it's something decimal point-ish like this, the 1.6, it might be on the calculator section. If it's solvable, if it uses crunchy numbers and whole numbers, then it can be on the non-calculator section. It depends, but honestly, it shouldn't be that big of a deal which section it's on.
Thank
No
you.
worries. All right. The next question requires a little bit more doing. Okay, on the architect's drawing of the floor plan for a house, 1 inch represents 3 feet. If a room is represented on the floor plan by a rectangle that has side lengths of 3.5 inches and 5 inches, what is the actual floor area? Area is important. Area of the room in square feet. So there's 2 ways to do this. One, you can convert the dimension lengths into feet. So we can do that right now. Okay, so 3.5 inches is the height dimension. So if 1 inch represents 3 feet, we cancel the inches units out. We end up with 10.5 feet. Okay? And then on the top, we have 5 inches, 3 feet. That's going to be 15 feet. So those are dimensions in real life. So then the area is just going to be 10.5 times 15. So that's going to be 157.5 feet squared. Make sure you put the squared in there, like mentally in your head. That's just good practice to have the correct units. So the correct answer is going to be D. Now, another thing you could do, here's one thing. So another thing you could do is find the area of the scaled down model and then try and raise it up to square feet. But there is a problem. There's a trap you can fall into when doing this. So I want you to be careful about it. If you find the area of the scaled down model, so we have to do 3.5 times 5. That's going to be 17.5. So the area of this dimension is going to be 17.5 inches squared. Some people, what they're going to do, they're going to do, 17.5 inches. I can just do 17.5 times 1/3, and the area is going to be 52.5, right? Because all we have to do is multiply it by 5, and they would have accidentally put C. Now, why did we get a different answer instead of the correct answer? Here's the reason. The unit over here is in inches squared, 17.5 inches squared. This is why I said you need to pay attention to your units, because here's what happened. You didn't fully eliminate the inches unit in that conversion we just did. That would have been 1 inch to 3 feet, right? If we cross out the inches, then there's in this inches unit, there's 2 inches units, right? So we cancel out the squared portion, but we're still left with 1 inches unit. And even worse, we're left with only 1 feet unit. We need a feet squared unit. So here's what's going to happen. We need to take our ratio and actually we have to square this thing in order to represent that we need to find feet squared. What that's going to do, 17.5 inches squared times inches squared, because 1 inch squared is 1 inch squared, basically. And then on the top, it's going to be 9 feet squared because 3 squared is 9. If you solve that, the inches squared and the inches squared cancels out. You do 17.5 times 9, and look at that. You ended up with 157.5 feet squared, the correct answer. All right, are there any questions? Sitara, you have a question?
Yeah, hi, can you hear me?
Yeah, I can hear you.
Okay, I was just wondering if there was like another way, because what I did was I just converted or multiplied 3 feet times the inches, like 3.5, and
Yeah.
then I got 15 and 10.5.
Oh yeah, I
And
mean,
then I
I
just
just showed
multiplied them
that
together.
method. I just showed doing that method at the beginning, actually.
Oh, really?
Just
Oh,
do it,
sorry,
yeah.
my screen was lagging, probably missed it.
Oh, okay, yeah, no worries.
Okay, thank you.
No worries. Yeah. But yeah, basically, yeah, there's two main ways to do it. The one that Sitara just mentioned and the one that I showed you just now. If you're doing the method I showed you just now, be careful that you pay mind to the units. Kieran, you have a question?
Can't you just multiply the dimensions by 3?
Yeah, that's I literally, yeah.
Oh, okay. I didn't hear you properly. I'm sorry.
Okay, yeah, no
Yeah.
worries. Yeah, that is what I said. Okay, now I know I've been doing a whole bunch of talking, but I still gotta do a little bit more talking. Okay, now we are going to enter a ratio problem where it's a little bit different. Okay, on Thursday we had 240 adults and children attending a show. The ratio of adults to children was 5-1. So let's write that out. 5. Okay, that is bad handwriting. All right. 5 adults, colon, for every. Oh, wait, no. My bad. That should have been children. All right. 5 children for every 1. Yeah, I really misreading a whole bunch of things today. I was correct the first time. 5 adults to 1 child. Okay? So we have 240 adults and children in total. How many children attended the show? Okay, here's the way you approach this. You see, what some people might think, they might think, oh, you just do 240 times 1/5, right? And that's going to give you the correct answer. Like it would have given you B, but that's actually the wrong answer. Because here's the thing, that's 240 adults and children. If you do this proportionally, the units don't cancel out. You get 1 child and 5 adults, right? These are not the same unit. So you can't cancel them out. What you have to do is you have to create almost a new unit. Think about it like this. We have 5 adults and 1 child, right? So if that is the ratio, technically we could say for every 6 people, there is 1 child, right? Because, if there's 6 people, 5 of those people are going to be adults, 1 of them is going to be a child. And that can actually help us because 240 adults and children, like just cross out the adults and children, basically are saying 240 people, right? So if we multiply it out like that, we get the correct answer, which is 40 children. So in a question where they are giving you the total amount of both of the objects they are talking about, in this case, the objects are adults and children, and if they're giving you the combination of both of those, you have to create like a new ratio that where the denominator or the numerator is the combination of both groups of those people as like a numerical total. So you can use that ratio to find whatever you need to find. Are there any questions about this? Sarita, you have a question?
Yeah, couldn't you also just make like a systems of equations, or is that just too much?
You could make a systems of equations,
Okay.
but the kind of stuff I'm showing here, you could do it in your head really easily.
Yeah. Okay.
All right then. Here are some practice problems. I'm gonna give you guys 3 minutes to do them starting now. All right then, everybody. 3 minutes are up, so let's come back and check out these two questions. First question is pretty simple. We have 100 people. The ratio of kids to adults is 9-1. How many kids are in the observatory? Okay, so we have 100 people. So if we have 9 kids and 1 adult, that means that there are 9 kids for every 10 people, right? So if we solve that, we get 90 kids. So A is the correct answer. The next question, a little bit of a two-step process here. Okay, for every 9 kids, there are 3 teenagers. I'm not gonna lie, I don't know what I was thinking when I was making that question. To be honest, the ratio should be opposite. There's way more teenagers than kids at Dave & Buster's if you've ever been in one, but yeah, okay. If there are 19 teenagers inside the Dave & Buster's, what is the total amount of attendees? Okay, it's a little bit different. We're finding the total amount of people there. So it's a little bit weird though, because we can't exactly or we can't easily find the amount of kids since we have a weird ratio. 19 doesn't fit well with 3. But if you notice, fractions, ratios, proportions, fractions, they're all kind of one and the same. You can actually simplify this ratio to something really simple, like 3 kids for every 1 teenager. So if there's 19 teenagers total, so 1 teen, 3 kids, that's going to be 57. Yeah, 57 kids. Now, some people, you might accidentally put A as the correct answer, but A is not the correct answer. We're looking for the total amount of attendees, so we gotta do 57 kids plus 19 teenagers. That's going to be 76 total attendees. So C is the correct answer. Any questions? All right, nope. Okay, we do have a question. Michelle, you have a question?
Yeah, so it was about like when you got to 57. So
Yeah.
what I did was that I just put 19 over 3 times 9 equals 57. Because
I mean, yeah,
I thought,
that also works.
yeah, because I thought if I try to divide 19 over 3, like teenagers, I think, I would try to find the children then.
Yeah. I mean, that method also works too. If it works for you and it's faster, then it's all good.
Thank you.
All right, more practice. Yeah, get to solving these ones. The first question's a little bit different. You're actually creating your own ratio based on the information I give you. Might be a little bit different. You don't have to worry too much though. I'm gonna give you guys, I think, 4 minutes to solve this starting now. All right, everybody. 4 minutes are up, so let's come back and check out these questions. So the first question, okay. For every 2 cheese pizzas sold, there are 4 pepperoni pizzas sold. And then for every 1 pepperoni pizza sold, there are 6 chicken pizzas sold. So we have to create a ratio. It's actually super easy to create ratios. All you have to do is, well, sort of combine them or multiply them together. First, we're going to make them into a proportion. So we're going to have 2 cheese on the bottom and then 4 pepperonis on top. And then we create a second proportion for our pepperoni to chicken ratio. So, oh wait, not 4. That's going to be 1 pepperoni. 1 pepperoni, 6 chicken. And if you multiply this out, the pepperoni units cancel out, and you end up with 24 chicken for every 2 cheese. Now you could say that A is the correct answer, but it's actually going to be the wrong answer because an important keyword, they ask for the simplest ratio. What does simplest mean in this case? Well, if you've been noticing, ratios, proportions, and fractions, they're all very, very similar to each other. And when we're simplifying a fraction like 6/3, we want to make sure the numbers are as low as possible to something like 2/1. So this ratio can be simplified easily into 12 chickens for every 1 cheese. So the correct and most simplest ratio is going to be C, 1 to 12. Okay, this next question. Okay, the ratio of eggs to bell peppers to carrots is 3, half, and a quarter. So James is making a big batch omelets. How many bell peppers is he going to need if he's making an omelet with 18 eggs? Okay, so here's the thing. You can take this triple ratio and sort of break it apart into whatever bits you need. So if we have 18 eggs, we know that for every 1 egg, or sorry, every 3 eggs, he needs half of a bell pepper. So we can write that out down here. For every 3 eggs, he needs half of a bell pepper. So if we multiply that out, we get 3 bell peppers. Easy like that. The correct answer is going to be D. Any questions before you raise your hands? Specifically, I mean questions about the content. If you struggled, if you found another method or another way to do this, that is really cool. But for the sake of time, all right, sorry for a second, my microphone changed for some reason. All right, yep. Back to what we were talking about. Okay, seems like we got a new type of question. All right, County Y has 2 districts. One district has an area of 30 square miles and a population density of 370 people. The other district has a area of 50 square miles and a population density of 290 people for every square mile. What is the population density for the entire county? So, okay, basically what's happening here is we have County Y split into 2 parts. What we need to do is we need to find the entire population density based on the information they gave us about each of the 2 parts. Now, how do we find the population density? Well, easy. We find the total amount of people and we divide it by the total area. So what is the total area of County Y? Well, that's going to be easy. All we have to do is we have to add these square mile areas together for each of the 2 districts, and we get 80 miles squared. Now we have to find the total amount of people. So we need to do a little bit of reverse engineering here. For District 1, how many people are there? We can figure this out by using the ratio they gave us, 370 people for every square mile. Let me write that in green, actually. Okay, so 30 square miles. For every 1 mile squared, there are 370 people. So if you multiply that out, it should be 30 times 370. That's going to be 11,100 people in total in District 1. Now, for District 2, what's that going to be? It's going to be 50 square miles. We create our ratio. So of 290 people, 50 times 290 is going to be 14.5K or 14,500. So all we have to do is add these 2 numbers up and we get a total population count of 25,600. And we divide that by our 80 square miles to get a population density of 320 people per square mile. So this is the correct answer. And before you make off with an answer, just consider if it's reasonable. You should, realize that because the population density is split between two districts, District 1, District 2, the population density should be somewhere between both of the population densities for Districts 1 and 2. So District 1's population density was 370 and District 2's population density was 290. 320 is somewhere in between 370 and 290, so it makes sense. You can't have a population density combination that is larger than the lowest density, so you can't have something that's lower than 290, and you can't have something that's greater than 370. That's like our upper and lower limits. Are there any questions on this? No? Okay, then let's move on. All right, I want you guys to try this out yourselves. I'm going to give you guys 3 minutes to do this starting now. All right, then, everybody. 3 minutes are up, so let's come back and check out this question. So it's a little bit different from the previous question. We're going to find the population density of a smaller area rather than adding up to a bigger area. So they're asking us for the population density of District 2. So in order to find that, we have to find the District 2 population, and we have to find the District 2 area. Now, finding the area is pretty easy because we know that County X, it's 100 miles squared in total, right? And then District 1 is 40 miles squared. So District 2 area is going to be 60 miles squared. Now, we have to find the amount of people that are in District 2. Now, how do we do that? We find the total amount of people, or, you could say like all the people in County X, and we subtract the District 1 population from that. So, yeah, let me just write that out fully. Okay, so finding the amount of people in County X. Okay, so it's 100 square miles and an average population density of 150 people for every square mile. So 100 square miles. All right, for every mile square, there's 150 people. So that's going to be 15,000 people. So we have a total of 15,000 people, and then District 1's population is going to be, 40 miles and then 200. So that is going to be, just 1 second. Yeah, 8,000. So there's going to be 8,000 people in District 1. So that means there are 7,000 people left for District 2. So we just put that 7,000 people right on top there. We do 7,000 divided by 60. What do we get? 116.67 people per square mile. Did I just say square miles? I meant to say miles squared. Okay, we don't have the exact answer here, but we do have the closest answer, 117. So B is going to be the correct answer. Any questions? All right, let's move on. Okay, this question. A furniture store buys its furniture from a wholesaler. Okay. For a particular style of table, the store usually sells a table for 75% more than the cost of the table from the wholesaler. During a sale, the store sells a table for 15% more than the cost from the wholesaler. If the sale price is $299, what is the usual price for the table? Okay, there's a whole bunch of confusing relationships getting thrown around right here. Basically, we have to find the normal price of the table, and they give us some important information from that. So let's create a few variables. Okay, so let's create the first variable, wholesale price, WP. This price is how much they bought it for. Okay, and then we have the normal price. This is how much that the store sells the table for. And then we have the sale price, which is how much the store sells for during a sale. Now, the wholesale price, they say, okay, they say that the store usually sells a table for 75% more than the cost from the wholesaler. So the normal price is going to be the warehouse price times 1.75. And then the sale price is going to be the normal price times. Oh, wait, actually, no, it's not going to be the normal price. You see, they said that the sale price is 15% more than the cost from the wholesaler. So it is still more than the wholesale price, but it's less than the normal price because it's WP times 1.15. Here's the easy part. They say that the sale price is $299. So if we know this is $299, then we can easily figure out what the wholesale price is. So $299 is equal to the wholesale price times 1.15. So wholesale price is equal to 299 over 1.15. That is going to give us an answer of 260. Okay, so the wholesale price is 260. So we can just reincorporate that back into our normal price formula right over there. Let me do that in a different color, actually. Yeah, we can incorporate that into our normal price. So normal price is equal to 260 times 1.75. That correct answer is going to be $455. So that means B over here is the correct answer. Yeah. All right. So, seems like we have a question. Harshini, you have a question?
Yeah, like, so will you tell us if like we need to use, I mean, if we don't need to use a calculator or?
Oh yeah, my bad. Yeah, I'll tell you if you need to use a calculator or not. Sorry if I've been forgetting to, but you know what? I'll say it like this: if it involves percentages and all that stuff, or any weird decimal numbers, then you can use a calculator.
Thank you.
No worries. Pranati, you have a question?
Yes. Why did you multiply by 1.75 and 1.15 instead of just 0.75 and 0.15?
Because that's not how additional percentages work. If you multiply by something, we're trying to say that we're adding 75%. And if you multiply something by 0.75 that is less than 1, it's actually going to lower the value. So we need to increase the value. So if you're multiplying something by an additional percent, you have to take the 0.75, you have to take that and add 1 to it. So that will give you the a multiplier that will increase by 75. Does that help a little bit?
Yeah, thank you.
No worries. All right, I would like you guys to try this out yourselves. Yeah, a bit of also a lot of whole bunch of things getting thrown around here, a bunch of proportions getting thrown around here. I'm gonna give you guys 4 minutes to do this starting now. All right then, everybody, 4 minutes are up, so let's come back and check out this question. So, okay, we have to find what percentage of the entire student population likes cookies. So what we're going to have to do here is we're going to have to multiply a whole bunch of percentages. Here's the thing. For some reason, people are like scared when I say, oh, you have to multiply percentages. It's really not that hard, actually. All right. So let's do it this way. Let's find out what percentage of cookie lovers is contributed by each grade. For example, sixth graders are 60% of the school population. We can represent that as 0.6 or 0.60. 90% of them reportedly like cookies. So if we multiply that by 0.90, then we get 0.54. Wait, just one second. Yeah, 0.54. So this means that for the sixth graders, they are contributing 54% to the percentage of the entire student population that likes cookies. Now, the seventh and eighth graders are each 20%. Let me just write that over here. The seventh graders are 20%, right? We represent that as 0.20. So are the eighth graders. So for the seventh graders, 75% of them like cookies. If you realize 0.75 is the same thing as 3/4. So you can do 0.20 times 3/4 in your head. That is easily comes out to 0.15. And then for eighth graders, only 25% like cookies. So a quarter of 20% is going to be 5%, right? So that's going to be 0.05. So if we add all those percentages up together, we get 0.74 or 74% of the student population at Yellowfields likes cookies. Now, I do realize this can be a bit daunting for people. So another way that you can go about it is to pretend that the total is equal, is to pretend that the total student population is equal to a really easy or crunchable number. For example, you can make a hypothetical scenario in your head where the entire student population is equal to 100 students, just for the sake of argument, so it can help you understand better. So if sixth graders make up 60% of the school population, that means there are 66 graders, right? And then 90% of 60 is equal to 54 sixth graders who like cookies. And then for the seventh graders and eighth graders, there are 20 of each, right? All this adds up to 100 students. So only 75% of seventh graders like cookies, so that's going to come out to 15 seventh graders, and then 25% of eighth graders like cookies, so it's going to come out to 5 eighth graders. You add all that up, that is 74 students. And you can clearly see 74 students out of the 100 students, 100 hypothetical students, like cookies. So that comes out to 74%. That was just a little bit of a more mentally easing way of doing it, I feel. Any questions? Nope. Okay, let's move on. Okay, reading graphs. This is pretty simple, so we're not going to spend too much time on it. Some questions are just going to ask you to look at a graph and tell them, what the information means or what part of a graph represents a certain thing that is happening. So the first question, for example, all right, Maria does a whole bunch of outdoor stuff for a total of 60 minutes. The graph shows her speed during these 60 minutes. What segment of the graph represents the time when her speed is the greatest? So all you have to do is look at the y-axis. It says speed over here on the y-axis. We have to find the place where her speed is the highest. So where is that? It's going to be right here. What does that correspond to? It corresponds to a time of 20 minutes and a time of 35. So all we have to do is find the coordinate points, or basically the coordinate points on the graph from the below answer choices that correspond to the time we found. Now, if you look at the bottom, the answer choices aren't all nice and crunchy in terms of the time. Some you got like 17 and 34 and 19. So what we have to do is we have to kind of estimate or get close to it. First of all, we can see that the maximum speed is 8. We can eliminate D because it has the maximum speed at 6 over here, and we can eliminate C because it has the maximum speed at 8 over there, but then it has it at 6 over here, which we don't want to see. And A, actually, we can eliminate that for the same reason. We can also eliminate, A and C for the reasons that actually, you see, A and C, they are representing a very, very short time period. You see, A, I believe, is representing this over here, and C is representing this dip over here. So the peak speed, it does occur between these 2 points at the very end, at the very beginning, but it's not representative of the entire high speed period. The only answer that does that is B, 19 and 34, 20 and 35, basically the same thing. And at that period, that is the period where her speed is the highest constantly. So B is the correct answer. All right. Next question. There's a graph over here, and I put a couple of hypothetical questions down there. This is what's called a scatter plot, where it's just a bunch of data, scattered across the coordinate plane. It's used as a data taking method, and it's used to find trends. Okay, so a grocery store sells a pint of raspberries, and the price per pint changes each week. The scatter plot shows the price and the number of pints of raspberries sold for 19 weeks, along with a line of best fit. The line of best fit is basically a linear line that takes into account every single data point, and it tries to fit the line best so that it tries to be as close to as many points as possible. And that can be sort of treated like a trend line. Yeah. Okay, so the below questions are sort of example questions. For example, according to the line of best fit, about how many pints will be sold if the price per pint is $4.50. So what we can do, we can use the line of best fit where we look at this price over here, $4.50. We see what number it corresponds around to. It corresponds to around 90. So we could say that if we sold the raspberries at a price of $4.50, we will on average sell around 90 pints. Second question, out of the 19 weeks, how many weeks were there where we sold more pints of raspberries than the line of best fit predicted? So basically the keywords more and line of best fit, we're trying to find points that are higher or above the line of best fit. So that means pretty much all of these points over here, we have to count them. So 1, 2, 3, 4. This one's on the line, so we're not going to count that. 5, 6. This one looks a little bit close, but you can see that the bottom of the dot's kind of edging out towards the bottom, so that doesn't count. And then 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So we can say that there were 8 weeks where they sold more pints than they predicted. Okay, and this next one, this last question's a little bit of a thinking problem. What does the line of best fit and the y-intercept of the graph represent? Okay, well, the line of best fit represents, how many pints you're going to sell depending on the price. And the y-intercept of the graph, what does it represent in this case? Well, what is the y-intercept? The y-intercept would be somewhere around here. Now, what does that actually mean? Well, look at the x value over here, 1.50. So that is a price of $1.50. The y-intercept is basically saying if you sell at the lowest price of $1.50, then you're probably going to sell around 190 pints. Now, here's another thing. You see, what if we had an x-intercept, but it extended a little bit further to where there's a price of 0 at the the x origin point, and we still went upwards. Let's say this was not where the y-axis started, but that this is where the y-axis started. If the x-intercept has an x value of 0, where there's a price of 0, that means that basically at whatever value is up here, let's say maybe 240, if you gave away the raspberries for free at a price of 0, then you would sell 240 of them. But that is actually a situation where you have to consider if there is any meaning to a statement like that, because you can't actually sell raspberries for free. You can't give them away. That's not the point of this line. And there might be questions. I just want to make you guys aware of these kinds of situations where you can have an x-intercept where the x value is 0, because sometimes there might be questions that ask you, does this y-intercept have any meaning? In the previous example, in the original graph, it does have meaning because the x-intercept has an origin point, or the lowest value of 1.50. Sitara, you have a question?
Yeah, just to clarify what you were saying, if there is like a 0 value present, should we not use that value? Should we just use
No.
like
I
the
mean,
next-
you can use it sometimes, but it depends on the situation. If there's a situation where a value of 0 doesn't make sense, then you shouldn't use it. I'm trying to think of one off of the top of my head. Oh, okay. Let's take this for example. Let's say we had a graph that represented, like, say, the amount of insects there were and the amount of noise they made. So, it increases this way and it, increases this way. Actually, wait, no, that's not a very good example. Okay, never mind. Forget what I said. That doesn't make much sense, but I'll say this. You'll know it when you see it. Rick, you have a question?
Yeah. So just to check, so are we allowed to assume that like they're direct points? So like for example, like $4.50 would be like 90.
Yeah.
Are we allowed to assume that if they ask us to like solve for the slope?
Yeah, you can assume that, if you eyeball it, they're probably going to make it, sure enough to where you can eyeball it and you can find the answer that way. But I
Okay.
want to say, like, if they ever have like a statement at the bottom that says not to scale or something like that, it means that you can't assume anything on the figure, okay?
Okay. Thank you.
No worries. All right, this is a conceptual word problem. This is just a little bit of a logic question. I'm gonna give you guys maybe 2 minutes or to just think about it. It's pretty easy, honestly. All right, then, everybody. Let's come back and take a look at this problem. So, conceptual word problem. Which of the following types of functions best models the number of books Jamal's library that the best models the number of books in Jamal's library as a function of time? Okay, keywords adds that corresponds to increasing. So let's eliminate decreasing and decreasing. He adds 2 new books every month. So it's a set interval. Every set period of time, it increases by a set amount. That sounds a lot like a linear relationship. So it's going to be A. C is exponential, where as time goes on, the increase increases more. So we're going to learn about that a little bit later. But yeah, for now, the answer is A. All right, here is a little bit of systems review. This should be a little bit familiar. I'm going to give you guys 2 minutes to solve this starting now. All right, then, everybody. 2 minutes, maybe a little bit more than 2 minutes are up. So let's come back and check out this problem. It's actually pretty easy. In the system above, A is a constant, so just any number. If the system has an infinite amount of solutions, what is the value of A? Okay, if a system has an infinite amount of solutions, it means that the equations are the same effectively. So they are proportionally the same. So we have to make it so that A is a certain value to where the bottom equation is going to be the exact same as the top equation. So we have to find a pattern. What's the pattern? Well, 5 to 10, 3 to 6. Obviously, the pattern is times 2. So we do 2 times 2. A should be 4, and therefore B is the correct answer. Are there any questions? Nope. Okay, let's move on. Okay, here is a mini quiz. Oh boy, actually, I don't know if we have a lot of time. You know what? In this case, I think we're gonna move on and do a couple of teaching for a few of the future topics, and then come next week or next class, we are going to start off with the quiz. I think that sounds good. All right. So let's talk a little bit about statistics and data analysis. This is pretty common on the SAT, where they're going to give you this grid chart full of data of basically scenarios where, you know, a combination of events happens and they tell you what the frequency of those events are. So basically, what you need to know from the text up above is that this there's a store and there's a whole bunch of customers. They got a security system and they're trying to track how many times the alarm is sounding and how many times it is correctly catching people. Okay? And basically in this grid, it's kind of representing a whole bunch of scenarios. For example, customers who shoplift and customers who sound, that that corresponds to value of 21. It's basically saying that there are 21 people out of the 10,000. 10,000 is the total right here. There are 21 people out of the 10,000 who tried to shoplift but got caught by the alarm. And then over here, for example, it says that there are 3 people who shoplifted and were not caught by the alarm, where the alarm did not sound. And then we have the vast majority of people where, you know, the customer didn't shoplift like any good upstanding citizen, and the alarm didn't sound. And then we have a couple of unlucky few who didn't shoplift, but then for some reason the alarm sounded. And then on the side over here, vertical side, we have the total amount of people who shoplifted. We have the total amount of people who didn't shoplift. And then on the bottom, we have the total amount of times the alarm sounded and the total amount of times that the alarm didn't sound. All of these pieces of information can be important. But for now, for the bottom question, we're only going to focus on a single row of information, or a single column of information, if you will. Okay. According to the manager's estimates, if the alarm sounds for a customer, what is the probability that the customer did not attempt to shoplift? Okay, this is you have to pay very close attention to the way they're saying things. They say, if the alarm sounds for a customer, so basically when they say if this happens, you have to only look at that row where the event happens. So they say if the alarm sounds, that means okay, that is like meaning we only have to look at this row. Okay, we have to assume from the get-go that the alarm is sounding and that they want us to only look at information concerning when the alarm sounds. Okay, if the alarm sounds for a customer, what is the probability that the customer did not attempt to shoplift? Okay, so we have to look at alarm sounds and customer does not attempt to shoplift. That's going to be 35 right there. There are 35 times where the customer did not attempt to shoplift, but the alarm sounded. What is the probability of this happening if the alarm sounds? So we have to do 35 divided by what? We have to do 35 divided by 56 because 56, that is the total amount of times that the alarm sounded. So if we are going to find the probability that if we're going to find the probability that a customer did not shoplift when an alarm sounds, we have to take the amount of times that a customer didn't shoplift when an alarm sounded and divide it by the total amount of times that the alarm sounded. What is that going to retrieve to us? Well, I'll just simplify it into 5/8, and because I have a good brain, I know immediately that's equivalent to 0.625. So D is going to be the correct answer. Now, here I want to show you guys a way that it can be phrased to where the answer might be drastically different. Okay, let's type it out like this. According to the manager's estimates, if the alarm, okay, what is the probability that the alarm sounded and the customer did not attempt to shoplift? You see, this is really tricky because they're actually telling you to kind of use the same information, the same keywords, alarm sounded and customer did not shoplift, but it's going to give you a completely different answer because what they're saying is they want you to look at the entire probability out of the entire population, this 10,000 as a base. What is the probability that these two events happened at the same time together? There's no if or what if. Basically, you have to do 35. You have to take a look at this event over here. 35 divided by the total amount of people there, 10,000. We're doing this because we're looking for the probability that these two events happen in conjunction. This question over here, we're already assuming that one of the events happens. So we're trying to look for the probability that the customer didn't shoplift when we already knew that the alarm sounded. So yeah, but back to this question, we do that, we would end up with the answer B. So for the question that I just showed, for the original question, D would be the correct answer. But for the question that I just wrote, B would be the correct answer. Are there any questions? Sitara, you have a question?
Yeah, why would it be out of 10,000? Because if it's and, can't you just do 35
Okay,
out
yeah.
of 56?
So the difference is that in the original question, they say if the alarm sounds. When they say if, it means that we are already assuming that this event happens and that we are only looking within this column. it's a little bit hard for me to like explain like how the logic is supposed to work, but it's like we're saying, okay, let's say for the, like sake of hypotheticalness, we already knew that the alarm sounded, and we're only trying to find the probability that a customer didn't do anything wrong if the alarm sounds. That's the situation there. The question that I wrote just now is saying, okay, what is the probability that the alarm sounds and the customer did not shoplift? What is the probability that these two events happen together in the entire population? If they give you a scenario where they're giving you two events and it's an and connecting them, it's kind of guaranteed that they're asking you to take the denominator of the entire population. If they're giving you like a what if scenario like that, then it probably means that the denominator is going to not be the entire population. It's going to be whatever the if statement is connected to. So the if statement was connected to alarm sounds. That means you have to take this as the denominator.
Okay, makes sense. Thank you.
No worries. Raquel, you have a question?
Can you show like a process on how you got 0.625? Like, can you like repeat that process?
Yeah. Unfortunately, since we don't have much time, I won't be able to go through that entire process now, but the VOD will be uploaded later, so you can maybe take a look at that since I went through it before, okay? All right. Histograms. Okay. This one's going to take a little bit of a longer time to explain, so you know what I'm going to do here? I am going to make it so that here's the plan. We do the mini quiz next class. We skip statistics and data analysis, which we just did now. We move on to histograms, and then we continue from there. So I am going to end our learning a little bit early today. If you have any questions, feel free to ask me in the group chat. Oh wait, actually, before you guys go, I want to say, I was told to tell you this, but you guys need to be practicing a lot. Practice is super duper important if you're gonna be successful on the SAT. So as a result, I'm just gonna give you guys like, a few tasks here and there. There is a website online. One of my favorite test prep websites is the College Board's official practice test website, where they give you old practice tests for free. I'll post the link in chat. All right, you can take a look at that link, and it has around 8 practice tests that you can work out of. And I would recommend that in between each class, you complete one section. So, before each class, you try and complete one math section like that, like one math section from test 1, test 2, test 3, etc. And based on what we're learning. And, that should be good practice. Review what you got wrong, and it should work out all like that. But yeah, that's pretty much all I have to say. If you have any questions, stick back for a bit. But if you don't, I'll see you on Monday. Bye. Have a good weekend. Saiti, you have a question?
Yeah, so my question is that, so for like the mini quiz, is it just something that we do on their notebook, in our notebook or something, and then you just tell us the answers like we usually do with the try it ourselves?
Oh, yeah, it's pretty much going to be exactly like that. It's just more questions at once.
Oh, okay. Okay, I just want to know that. Thank you.
Yeah, no worries. Hude, you have a question? Bye.
Is the video going to be uploaded on the WhatsApp group?
Yeah, we just uploaded the video today, actually. I'm gonna share the link in the WhatsApp group.
Okay. The video of this session?
Sorry, the video of the last session. We do have the recording of this session as well. It's gonna take a little bit of time to upload, maybe expect it within the next few days.
Okay, all right, thanks.
No worries. Katya, you have a question?
No, you just answered it. Thank you.
All right, no worries. Srikanya, you have a question?
Yeah, so we've been doing a lot of math sections recently, and I just
Yeah.
wanted to know when we'd go on to like the reading and grammar stuff.
Yeah, okay. So reading and grammar, what I like to do, I like to do all the sections, at once. So like series of math and then series of reading, writing. So we did 2 sections of math so far. So I would say the next 3 more sessions, that's gonna be math, and then the remaining 5 sessions is going to be reading and writing. Okay, Devi, you have a question?
So for the furniture question,
Mm-hmm.
when you were trying to find the original price,
Yeah.
why'd you divide the warehouse price and then multiply the normal price? Why didn't you just divide both of them instead?
Um, I'm sorry, I don't remember the exact process I did. All I could say is that I double checked my answers and I did get the correct answer. So the only thing I could say is wait for the VOD to come out and check to see how the process went from there. I probably explained it during that. Sorry. Arnav, you have a question?
Yeah. So what are we gonna be doing for like the rest of the math sessions? Because I think there's like algebra 2, a little bit of algebra 2 left, right, to cover for math.
Yeah. We're gonna be covering a little bit more algebra 2 later, but the next few sessions are also going to be, I think the sessions 4 and 5 are going to be very, very geometry heavy.
Okay. And also, do you recommend Khan Academy as like a good source for SAT prep?
Yeah, sure. Khan Academy is a great resource prep. I mean, it's free, it's decent quality. I never ever say no to it. But if you want one company like a physical book that I'd recommend, Barron's prep books are super good because they're actually hard and they really kick your butt. So really train you for the actual test super well. Like I remember when I took a Barron's test my first time, I was getting like, 790s, 780s on the other exams. For the Barron's, I got like a 650 on my math portion, so it was really tough.
Okay. Thank you. Have a
Yeah,
good
no
weekend.
worries. You too. Bye. All right, then I'm heading out now. Have a good night, everyone. But yeah, that's pretty much all I have to say. If you have any questions, stick back for a bit. But if you don't, I'll see you on Monday. Bye. Have a good weekend.